I will be speaking on analytical and technical analysis of the computing concepts and applications with emphasis in predictive analysis, lattice, quantum, chromodynamics, and computational cosmology. This the abstract of my talk is the studies related to the concepts of advanced computing have been reviewed and discussed. The applications of advanced computing in particle physics, networking, and data handling have been discussed. The facilities required for advanced computing are also briefly described. Special emphasis has been placed on the role of advanced computing on science and technology. Simulation for optimization in predictive analytics and also for maximizing the output and profit of the commerce and industry have also been briefly discussed. Design considerations for lattice quantum chromodynamics QCD have been presented in this talk. The treatment has been based on expressing the strong interaction between quarks. These are special particles in nuclear physics between quarks mediated by glucons. Again, they are particles, fundamental particles, and considering the space-time lattice to be distributed across all the nodes. The lattice QCD this refers to d meson semi-planometric decay amplitudes as reported in the literature have been technically discussed. Comparisons between QCD, quantum electrodynamics, QED and QCD have been briefly brought out, and a brief description of the simulation of large-scale structures, cosmic web of dark matter, filaments and halos has also been given. The paper is expected to be useful to the new entrants in the field and also for the senior technologies in the scientific fields. This by the term semi-plotonic decay of a hadron that is a decay caused by the weak force in which the lepton and the corresponding neutrino is produced in addition to one or more hadrons. An example of this is K leads to E electron. Now, after this, I have given this talk, this manuscript here before you. That was meant for more than 1 hour, but now because of 25 minutes duration, I have marked the important portions that I am going to give. These are in red color or blue color. So I will be reading that, and you can skip over the other given in the normal black mode. In theoretical physics, quantum chromodynamics is the theory of the strong interaction between quarks mediated by glucons, the fundamental particles that make up composite hadrons such as the proton, neutron, and pion. QCD is a type of quantum field theory called a non-abelian gauge theory with symmetrically grouped SU. Now, quantum chromodynamics QCD in physics, the theory and describes the action of the strong force. QCD was constructed in analogy to the quantum electrodynamics. Actually, there is a parallel sort of thing between the two, and the quantum field theory of the electromagnetic force. Now, after this, I just want to give in one sentence what is advanced. What do we mean by advanced computing? In fact, a computer's infrastructure combined with an operating system OS is able to embed and distribute the information throughout a computer's architecture, which ensures the elements working in conjunction with one another for providing the capability of a computer. To operate effectively. The IEEE held an advanced computing conference which covered the gamut in technology in the report. This is given in the reference 4 here in this paper later on. If anybody is interested in, then he can go through that paper and get an idea. And for one thing, before starting further, I want to tell that because this concept and the topics that I'm going to cover are many, therefore probably in 25 minutes or so, it will not be so much clear for the audience. So I am saying that anybody who is interested in knowing more about this can always contact me on email. Then I will be able to clarify all the points that are in their query. First topic is simulation for optimization in predictive analytics and also for maximizing the output and profit of the commerce in an industry. So this is used now in commerce and industry also, because these concepts are not only used in, as I am saying that I will be discussing in particle physics, etc. It's research, but apart from its uses in research, they are also useful in commerce and industry. Though the advanced computing is mainly applied in science and engineering, it can also be applied very usefully for corporate sector, especially where the data of number of employees, years of work under consideration, wages, and performance incentives, in addition to the some unseen situations to achieve the optimum solution in minimum time. So we want that the solution should be optimum, time should be minimum, and output should be the maximum. The simulation for optimization of learning in scientific and technical organizations is similar to the one for predictive analytics and also for maximizing the output and profit of the commerce and industry. This is given in references 5 to 11. One can go through those references and have a broader idea about the things. Those simulation used to just focus on learning in scientific and technical organizations is based on computations by using commercially available software. Advanced computing can be more important purpose for the base level learning, for which BI is most important. And these I am giving some parameters, and just to give you an idea what is the subject about, for which BI is the most important and commonly used parameter of cognitive architecture, ACT minus R. This is ACT minus R is the cognitive architecture. Following the approach which is given in 12 reference, the equation for estimation of the log odds of all presentations of a group being used is given by BI is equal to log of this expression number 1, where TI denotes the TDJ minus is equal to T minus T presentation, T normal and T minus T presentation, where the group is represented in memory, and DR denotes the decay time, and in ACT denotes the initial activation. It is to be noted that the base level learning defines a logarithmic power function which approximates the power law of forgetting when no chunks are presented, and the power law of learning when many consecutive chunks are presented. So these are two different things which are interconnected. The manager of the organization has to note that the parameters of the base level learning equation can assign different rates of degradation of each individual or each group, and thus allowing the individual to forget when no representation of a group takes place, and also enables it to remember when representation takes place. As is expected, the declarative groups are expected to expected gain or utility. If the manager is involved in solving a goal, the individuals can be asked to solve the problem. But as ACT minus R is a serial processor, the procedure has no choice other than selecting the one with the highest expected gain or utility. In that approach, the utility U is given by the expression number 2, and where P denotes learning probability, GV denotes the goal value, that is the importance attached by ACT minus R to achieve the particular goal. C procedure denotes the cost of using the procedures, and sigma denotes the stochastic noise variable. So something, in addition to the normal thing, some sort of noise is there, which means any other possibility which is not foreseen that takes place. Therefore, that also affects the optimization. It is clear that it is possible to assign a different G value to each procedure, which influences the ACT minus R engine for choosing a specific procedure. However, in general, it is customary to assign the same goal value to all procedures in most of the ACT minus R simulations. In fact, the probability P, capital P of learning is a factor of 2 sub probabilities QI, the probability of successful procedure, and R, the probability of fulfilling the objective. One is what is the objective and the probability. Second is probability of that procedure leads to success. The probability of fulfilling the objective of the goal in case the procedure is unsuccessful. And P is capital P is defined as not in a position to follow any other procedures having similar parameters. It is important to understand the procedure for learning parameters Q and R, since they have strong impact on the behavior in the capital P is Q star R. That is expression number 3, which is the probability of learning function. Also for cost C procedure, generally sigma has to be added to the utility for creating a non-deterministic behavior. As I was telling, sort of noise. This behavior is previously not determinable, and therefore it is non-determinist behavior, any eventual thing that is happening there, and not with the deterministic behavior. Another important aspect of learning connected with the procedure is that it is of two types: procedural symbolic learning and the procedural sub-symbolic learning. In the first type, ACT minus R distinguishes between specialization and generalization, in the sense that the specialization is used for often recurring problems again and again. They are faced and become routine and generalized, in which is used in analogic problems. Surprisingly, ACT minus R has no stable and clear solutions for the problem of this type of procedural learning. In fact, the procedural sub-symbolic learning is more prominently used in such studies. In this technique, the parameters of the probability Q and R describe the success rate of the use of procedure and reflect the frequency and occurrence of successes and failures in the production. Here I want to emphasize that because so many things I am telling, therefore I am sorry if there is a problem in understanding, but the objective of the present talk is to introduce the subject, and then the audience can think over this if anybody is having an interest, and then interact with me later on. Obviously, the parameters Q, obviously the parameter Q is the success ratio of the directly completing the procedure, which in fact keeps record of the most recent successful execution of the condition and action achievements of completing an objective of a goal after solving all the sub goals and after achieving and popping the current goal level. In other words, all goals that follow the current goal have to be fulfilled successfully to accomplish the current goal. The learning probability is defined as Q comma R is equal to S upon S plus F. This is equation number 4, which makes it clear that in the beginning either S means successes, R is equal to 1, or F failure is equal to 1, leading to 1. By default, an initialization of the procedural parameters, S is given a value of 1 and F given of value 0, obviously, which is based on the optimistic view of the success of the procedure being followed. It has to be carefully noted that so far the simulation treatment has not considered any time component, which implies that the events and efforts in the past are equally weighed as in case of those experiments experienced presently. However, in general, the organizers are observed to be more aware of the impact of the present value events and experience than those of the past. Therefore, ACT minus R is modified by using the functions to discount the impact of the past experiences by incorporating a power decaying function, which is similar to the base level learning equation. The modified formula for discounting successes and failures is given by this expression: S versus F is equal to summation of this term, and this is expression 5, where M is the number of successes or failures, Tj leads to time difference, and D is the success decay rate. The organizer uses this formula to give different decay successive decay rate. The organizer uses this formula to give different decay the performance of the organization by optimizing various parameters for which his experience is very important. On some complicated cases, use of software is also required. And it is important to note that in certain cases, it is possible to extend the analysis by including the individual experiences and memory of the past experiences. And then this formula is modified to utility is equal to 1 plus S upon 1 plus F, which is equation 6. And it is obvious that when t is equal to 0, the individual has no preferences, and he selects based on his experience and or randomly. However, in the ACT minus R simulation, the utility computation is quite complicated and noise has to be added to compensate for the variance in decision making. Because in decision making also it is a very complicated job, and so many things are for there for taking the decision, and therefore in this we add the noise to compensate for the variance, that is the variance, the ordinary the parameter that is in statistics. In addition, in the simulation experiment, the individuals are provided with an equal personal construct, which means that the initialization parameters of the employees are equal, implying that they have equal decay rates, equal utility preferences, equal motivation value to solve the goals, and equal procedural declarative memory and noise. And now there are so many design considerations of lattice quantum chromodynamics, and this I leave, but only something I am telling about this, that it is to be used in theoretical physics. The quantum theory explains the strong interaction between quarks and gluons, the fundamental particles that make up composite hadrons such as the proton, neutron or pion. In a similar manner, QCD is a type of quantum field theory and non-abelian gauge theory having symmetry group SU3. Advanced computing is widely recognized as an expansive term used for portraying of QCD, analog of electric charge. It is analog of electric charge is a property called color. So this has application in color confinement. The importance of the underlying physics can be judged from the fact that this theory is an important part of the standard model of particle physics. On the basis of many theoretical and experimental investigations, a lot of experimental evidence has been obtained for the QCD. It is important to note that QCD is an important concept as it exhibits two important properties. First property is color confinement, which is due to the constant force between two color charges as they are separated. So color is confined there. This is explained as with an increase in the small, this is explanation, the small explanation, with an increase in separation between two quarks within a hadron, increasing amounts of energy are required, which finally results in the production of a quark anti-quark pair, and thus turning the initial hadron into a pair of hadrons instead of producing isolated color charge. Due to this, so there is no isolated color charge, and therefore color is confined. Due to the color confinement, quarks cannot be directly observed or found in isolation, and can only be found within hadrons, which include baryons. These are different particles in that physics, such as protons and neutrons and mesons. This is why the quarks have been mainly studied by observing hadrons. And the second property is asymptotic freedom, which in fact is a steady reduction in the strength of interactions between quarks and gluons as the energy scale of such interactions, thereby decreasing the corresponding length scale. This is given by, term is S Dirac. This is easily understandable for the people in persons in this particle physics, where the Dirac operator D is given by this expression 8, and it can be visualized that the lattice QCD uses discretized space and time, and given the lifetime, a very discretized form of Dirac operator is given by this complex term 9, where A is the lattice spacing. These are the parameters which have to be considered for solving this problem, and psi x is a quark which depends on psi x plus a mu and the local gluon fields u mu. Clearly, psi x is complex 3 into 1 vector, and the u mu are complex 3 into 3 matrices. It has to be noted that the interactions are computed via matrix algebra. So you have to use this matrix algebra also for solving problems in this particle physics. And on a supercomputer, the space-time lattice can be considered to be distributed across all the nodes, which is reported in the literature having been shown below. This is that picture. This is distribution of space-time lattice across all the nodes. So if you go through the subject, then you can appreciate the value, the importance of this figure. So it has now been well understood that for achieving the desired results, the latest QCD mode codes MILC expressed by the MIMD lattice computation collaboration Chroma using C++ and running or any MPI machine, and CPS uses C++ and running on QMP machine they require these things. Number one, excellent single and double precision floating point performance. Number two, high memory bandwidth. Number three, low latency. And these are some of the things that have to be considered. The next paragraph, this QCD is a theory of strong interaction in the form of non-abelian gauge theory, invariant SU3. This I have already touched. So there also the interaction is governed by massless spin one. This special spin is a unity and it is massless, and that is why these are called glucons. These are just named as glucons. Glucons couple only for two objects having color, implying quarks and glucons. So color is represented by these two particles. There are three different charges, that is colors. Here the different charges mean different colors, the red, green and blue. In contrast to the fact that QED, there is only one charge, that is electric charge. There are 8 different glucons. Okay. Now there is some comparison between QED and QCD. I am skipping over this. Anybody you can, because manuscript is there, you can see this. This figure shows this is the picture of computational cosmology. It has been observed that the high performance computing HPC has proved to be integral and indispensable part of cosmological research, and during the last 10-15 years has become one of the most important tools in explaining the most fundamental problems in cosmology. The huge data collected from the various investigations has to be analyzed for cosmological information, and in fact, this MA is cross-cutting and science-enabling MA, which interacts with the various research MAs for helping them to achieve the goals. And this is the Hubble Extreme Deep Field XDF as reported in the literature, and this has been reproduced here. This you can see that the theory has this application in space also. This figure is courtesy Hubble Observatory, and it is to be noted that XDF has completed in 2012 some galaxies which are 13.2 billion years old, and there are 2 trillion galaxies like this. And you can also see this cosmic web of dark matter filaments and halos. This is again figure courtesy this Chicago .edu, and I think now I'm concluding my talk. That quantum computing is showing great potential to solve computational challenges in aircraft modeling, simulation, and many related problems, including speeding up aircraft design, debugging millions of lines of software code, and resolving complex computational challenges. In addition, educational institutes and research agencies have been showing more interest in this field. Thus, it can be safely concluded that the field is on a firm and evolving footing. And recently, some space or aeronautics corporate sectors are also making use of this advanced computing. And I am sorry, I was getting this notification that some of the things are not visible. not shown coming on this, but I could not do correction from here. But I am again requesting that the people can go through this. That is why instead of giving slides, I have given this full manuscript so that you can see some of the my own references are also there, where the papers have been published in Canada, Journal of Banking and Commerce, Ottawa Banking, and some are in economics, Singapore also, where from business point of view, and then they are in finance studies also, Los Angeles, California, USA. Some paper has been, there's a technical overview of the concepts of finance studies and the methodology of optimizing the financial resources. So different fields, even in science, some papers have been published. I have here mostly this last, you see, Boeing Lattice launches new organization of to unleash the power of advanced computing and networks in aerospace, Chicago, USA, 2018. So you can see that people more and more, this 16 also, aerospace engineering, Iowa State University catalog, again USA. So different types of organization are coming into this and making use of this software infrastructure. And let us hope that we are able to solve more problems on this in this direction by making use of this advanced computing. And this is now being used in this AI also. And therefore, I think we are going to see so many new developments in this, because artificial intelligence, AI, is being used now in most of the fields. And I think my idea is that we will be hearing more and more about this. And I request the people who, in mathematics, people who are very strong with this background, they should take up this type of problems so that they can serve the scientific organizations as well as corporate sectors. That is probably all that I wanted to say in this small amount of time. And now anybody who is interested, he can ask me question, or otherwise he can correspond to me by email, and I will be able to, I will, to the best of my ability, I will try to solve the problem.
Thank you very much, Dr. Chopra.
Solid, pleasure is all mine.